Hello, Professor. This is Justin Miller demoing for me and Andrew. I'm going to show you the 1-bit full adder. This is our code, coding in the variables, the STG logic vector, adding our XOR gates and AND gates. And then we have our test bench, which shows the signals in our variables and the signals with the values, and then the instantiate the unit under test, which is basically just porting or mapping our variables to each other. And then we have our stimulus process, which drives our variables, and then the end. And we'll simulate it for you. As you can see, we get this, zoom to fit, zoom in, we get that. I can zoom in a little more so it fills in those gaps right there. There we go. And then I can take Easter time, go all the way over. Oh, I'll see that. Just go to the beginning of time. And as I move the timer, you can see it step through our program as the values change, and it finally comes to an end over down there. And it will keep changing until it gets to the very end. Oops. I don't know why it did that. And we can go all the way to the end, and we get 1, 1, 1, 1. Close this simulation. Make the mux. Set this one top. Set this one as top. Run the simulation. This is what we get. Just a bunch of blocks, but if you zoom to fit, you can see the waves and the block diagram, and you can zoom in even further to see, zooming on time basically, and you can see the blocks change. And also each block represents a value. As you move it, you can see the values change again. Eventually we get 1001. Close this simulation. The mux. We have our variables, STD logic. We have our if-else statements. If select 0, then mux out is in 1. If else mux out is in 2, and if 2 to 1 mux. And then we have our test bench, which is basically again mapping our variables and giving them values and adding the stimulus process in the unit under test. And then let's do the AND word. So this top. Top. I'll go over the code with you briefly. So we have our width, so we have enough width, basically size, and then we have our the architecture, begin, AND bits, process A, B, begin I and Q range loop. And this basically loops and puts an integer in each one of these. And this gives them values and maps the variables to each other. And I will run the simulation. You get that. Zoom in. I could do this and keep it as hex. Or I can get more scientific, change it to binary. Change it to binary. Change this one to binary too. And for my eyes, at least, I get a better idea now of what's going on. I hate this thing. I really hate this. Sorry. So when you move this again, you can see the values change in binary, or if I changed it to hex, you can see them change in hex. But this binary is visually easier for me to understand. And as it finishes, don't do that. We end up with 2 for B. And then close this one. Just go simulation. And then we will do our last one. Our OR. Set as top. Or word using the BEH function. And let's look at the code real quick. Basically giving it enough size. Adding the loop in again. But this time we're using OR. Subband. And then we can go to the test bench where it gives it values and maps the ports. And then for this one, we use the begin. Well, it's the drive process, so we always use begins. I just forgot to put the drive process comment. And we are giving this one values. So let's run the simulation. We get this. Zoom to fit. And we can also put this in binary. You gave it binary value, so you might as well do it in binary. And you can use the timer to step through the program and see it doing its OR function all the way to the end. And that's what we got. Thank you, Professor. Sorry if this was a long video. I hope you understood it. I tried to do it as quick and efficiently as possible. Please give me any feedback. We uploaded everything into our file, and I'm going to add this video as well. Thank you. Have a good weekend. And yeah, thank you.